How's it going, everybody? I'm Lee from Socially Awkward. And the holidays are coming soon, and I know that some of you have some New Year's resolution to either start learning Unity or even finish making some games. Luckily for you, I am working on a 2D platformer where you're gonna play as the big man himself, Santa Claus. You'll be running and jumping through snowfields, and best of all, I'm gonna be teaching you how to make this game. This 6-part tutorial is a great start for whether you're new to Unity or even if you have a little bit of experience. I don't have much else to say, so let's just get right to it. To start off, we're going to go ahead and create a new project. And for this, we're only going to need the 2D core. You can name the project whatever you want, but for now, we're going to leave it as is, and you can go ahead and create project. Unity is going to start creating the project, and it's going to take a little bit. So the first thing we're going to do in our empty project is we're going to create the player character. We're going to right-click, create a new 2D object, sprite, and capsule. And then we're just going to go ahead and rename that object to player. And while we're here, we're going to go ahead and add a capsule collider 2D. As well as a rigid body 2D. And while we're at it, we're going to create another 2D object, sprite, square. This is just going to be a platform for our character, so we want to move it directly underneath and have it stretched out. We're also going to go ahead and add a box collider 2D so that when you hit play, the player won't fall through the platform. The last bit of setup I'd like to do before going into some code is making sure that the game object's Z-axis is constrained. That way, when it's running and jumping, it's not going to suddenly fall over. We want the player to always be standing upright. Right, let's get into the scripts. We're going to first right-click in the Files Inspector and create a new folder called Scripts. Let's go into the folder and then right-click, create C# script, and let's call that Character Controller. So for the first thing, we know that we're going to need the rigid body to move the character around. In order to do that, we're going to need to create a variable type of rigid body 2D. And let's name that _RB for simplicity's sake. And then inside our start function, we're going to assign _RB to get component rigid body 2D. With the Unity input managers, we can detect the movement of a joystick, either moving horizontally or vertically. That same input can also be applied to a keyboard. We can use WASD, where W and S would be the vertical input and A and D would be the horizontal. And the same can be applied with the directional keys on the keyboard. For the sake of this game, we won't be using any of the vertical movements. We're just going to be using the horizontal to move left and right. To capture that data from the horizontal tilt, inside update, we're going to create a float called horizontal tilt, and we're going to access the raw data of the horizontal axes from input.getAxisRaw horizontal. And from there, we're going to use that value to create a velocity that we'll apply to _rigid body. So _rigid body.velocity, and we'll create a new vector 2 where the x value will be the result of that horizontal tilt. And we'd like to keep the y velocity of the player in case of falling, which we can refer to by _rb.velocity.y. And to test this out, we're going to drag our script onto our player. Once we hit play, we will be able to move around. Now you'll notice that the speed is quite slow, so let's fix that. We'd like to be able to adjust the speed in the inspector, so what we're going to do is we're going to create a serialized field, and we're going to create a private float variable called speed. And for now, let's just assign that the value of 5. And in our velocity, we will multiply the horizontal tilt to the speed. When we hit play, our player should be moving a bit faster. For a bit of cleanup, I'm going to move the calculations of the velocity into fix update, which happens in regular intervals. Because update happens more frequently, I'm going to keep the input in update to ensure accuracy. But since the velocity uses horizontal tilt, I'm now going to need to make horizontal tilt a property of our class. And if we hit play, it should run exactly as it did before. And as I mentioned before, you should be able to change the speed inside the inspector. So while the character moves just fine, there is a little bit of an issue that I have with the actual movements of the character. It doesn't really feel natural. When you stop the input, the character just abruptly stops. In nature, it's a little bit more natural than that. There's acceleration and there's deceleration. So if this is the player, when we start moving, we're going to start at a slower pace and then we're going to slowly reach to a maximum speed. And then when we stop moving, we're not just going to abruptly stop, we're going to slowly decelerate until a stopping point. So this is something that we would need to implement into our controller script. Now in order to achieve this, we're going to first need to create a serialized field, and the variable will be a private float acceleration. And for the time being, I'm going to assign it 0.5. We're also going to need to capture the current speed at all given moments, so we'll create a variable float called current speed. We're also going to rename the speed to max speed, since this will be the speed that we do not want the current speed to be exceeding in either the negative or positive values. Now, since we'll be calculating the speed in a different way, we're not going to need this original line that we wrote. Before we write the logic for the updated movement, I always like to lay out the steps in comments. First, we want to calculate the current speed based on the tilt and acceleration. Second, we need to clamp the speed so that it never exceeds the maximum. Finally, we want to apply the speed to the rigid body as a velocity. Great, let's code it out. Current speed plus equals horizontal tilt times acceleration. For the next part, current speed equals mathf.clamp current speed, and we want to make it the negative maximum speed and the positive maximum speed. That way it'll never go past the maximum in either directions. For the last line, rigid body.velocity equals a new vector 2, just as we did before, with the current velocity, and we're retaining the current y velocity of the player. Now when we hit play, we notice the player glides. In order for the player to stop, we need to decelerate the player when there is no input. Just like before, we will lay out our logic with comments. First condition, if the horizontal tilt is not 0, add to the speed. Second, if the tilt is 0, slowly decrease the speed to 0. Now with code. We start with if horizontal tilt is not 0, followed by the else. We'll copy this portion of our movement logic. And for the deceleration, current speed equals mathf dot move towards, and we want the current speed to approach 0 at the same rate as our acceleration. When we hit play and move, our player slows down when we don't press anything. And in the inspector, we can adjust the max speed and the acceleration as well. Now if we go back to our code, we can actually simplify and combine the two lines. We can write current speed equals and copy the mathf.clamp. And then we can copy the calculation here and add it to the current speed in the clamp. We can get rid of these old lines and move the comments since it still applies. If we hit play, everything should still be the same. Before we move on, we should clean up a bit. I'm first going to group these variables with a header called movement. When we go to the inspector, we can see that header. I'd also like to move all the movement logic into a function called update movement. Let's copy the logic in. Then we will call it in fixed update.
Now that we got our player moving with a little bit more natural movement, let's get the player jumping.
We'll start with a header called jumping. And we'll have one serialized field float called jump height. Let's set that to 3. Now I want a function to make the player jump. We'll call that start jump. And we'll lay out the logic. First, we will calculate the force required. Then, we'll apply this force onto the rigid body. We'll start with float jump force equals. Now, the math for this is something I've used for years. I don't remember if I found it or came up with it, but regardless, the math is math.square root jump height times -2 times physics 2D dot gravity dot y times rigid body dot gravity scale, and then multiply it with rigid body dot mass. Next, to apply the force, we use rigid body dot apply force, and we'll use a new vector 2 with the x value of 0 and the y value of jump force. And then for the force mode, we'll use force 2D dot impulse. Next, we go up to the update and create a section for the actions. We'll check if the spacebar is pressed, and then call our start jump function. If input.getKeyDown keycode.space, and then we'll call our function start jump. When we hit play, we can use space to jump. We can also adjust the jump height, and the player will always jump exactly that amount of units, and that's thanks to the math. But you might notice that we can keep hitting space and get our player to constantly jump. Let's fix that.
So in order for our player to know if it's on the ground, we're going to use ray casting. Let's take our ball again and imagine this coaster is the platform. So what we're going to do for the ray cast is we're going to draw a line from either sides of the player object downwards towards the ground. If that line hits something, then the game will know that the player is on the ground. For the sake of this game, we're only going to use 2 ray casts, one on either sides of the player. The downside of this is that if the player is on a smaller platform, we're not going to be able to detect the ground because the ray cast isn't going to hit anything. But I'm going to build this with the anticipation that all of the platforms will be wider than the player.
For the ground detection, we're going to create another header called ground detection. For the variables, first, float ground distance and vector 3 collider offset. For the raycast. Also for the raycast, we need a layer mask called ground layer. Finally, we need a boolean for confirming we are on the ground, and that will be false by default. To visualize the raycasts, we will add an existing Unity function, onDrawGizmos. We first set the gizmo color to color.red, but you can set it to anything you like. We will then draw a line on the right with gizmo.drawLine, the first value being the starting position of the line, and that will be transform.position plus collider offset. For the end position, it'll be the same with transform.position plus collider offset, also adding vector3.down times the ground distance. We will copy it, but change these to minus. Going back to the editor, we can adjust the ground distance and a red line will appear. We want this to end just below the player. We will also adjust the X value of the collider offset, so the lines are just to the edge. We won't need to adjust the Y or Z values. To use the ray to check the ground, we will create a function checkGround. We will set to check with the onGround variable. Then raycast with physics2d.raycast, starting at transform.position plus collider offset. The direction will be vector3.down. The distance is ground distance. And we'll be checking for the ground layer. That's for the right. So we add an OR, copy the statement, and change the plus to minus. Let's go up to Fix Update and add this function. And then we'll go back to Start Jump and add if not on ground, return. With that, we should now only be able to jump while on the ground. But to make this work, all ground must be on the same layer mask. So let's go to our platform. In the layer dropdown, click on Add Layer. We will call this layer Ground. Going back to the platform, let's assign this layer. And inside our character controller, let's assign ground layer to the new layer we just created. When we hit play, we should be able to jump only if we're on the ground. You can try to keep on hitting the space button, but we're only going to jump if the player's on the ground.
In a lot of modern games, we want a little bit more control on what the player can do, even if that doesn't really make sense in a physics standpoint. In real life, when you start a jump, the power of the jump and the height is already determined from the moment you lift off the ground. But when we're playing a game, we want more control, so we want to be able to stop the jump. So we're going to write in an ability to cancel the jump, meaning we'll cut the jump short the moment we release the jump button.
Let's create a cancel jump function. We will check if rigidBody.velocity.y is greater than 0. Because we can't just set velocity.y to 0, we need to create a new vector v, and we're going to assign it to rigidBody.velocity. From there, we're going to assign v.y to 0, and then we're going to set rigidBody.velocity back to v. And then back at our update function, we're going to add if input.getKeyUp keycode space, and then we're going to call our cancel jump function. If we hit play, we can use space to jump, but if we release early, the jump will be shortened. This feels much better. Now that we have most of our movement script in place, I would like to adjust a few numbers just to get it feeling right. The benefit of having these values shown in the inspector means that I can play the game and adjust as I go along. I'd like my player to move a little bit faster, and I'd also like my player to jump a little bit higher. I'm not very fond of this floaty jump, so I can go into my rigid body settings, and I can modify the gravity. Once I have these settings just the way I like it, I can save the scene and we're ready to go. And lastly, I'd like to rename the scene. Sample scene doesn't really mean much, so let's change this to level 1.
And with that, you now have a character that runs and jumps. If you have any questions, feel free to leave it in the comments below. Or if you have any requests for other tutorials, leave them there as well. If you want to keep up to date with any tutorials that I post in the future, be sure to hit the like and subscribe button. For the next video, we're gonna add tackling and a butt stomp. And that's it for this one, guys. I'll see you in the next one.